Now we want to figure out how to start tuning with the DSP. And what we mean by DSP is digital signal processing. And I've got a cool little product up here in front of me, which is one of our amplifiers. You guys are probably familiar with the PXA amplifiers. That's the one that was in the fish tank over here for 14 months, like underwater, working. These things are just incredibly durable. If you have one of these amplifiers, and I know we mentioned this a couple episodes ago, and you're not aware of it, they've always had DSP tunability built into them. We just now, in fact about 2 months ago, started shipping this little guy, which is the DSP interface, the little tuning dongle. It's just an adapter to allow a USB-C to plug into this and allow it to plug in the amplifier. And the way it's done is you take the cover plate off the amplifier, which you've got some nice controls on the amplifier. Your crossovers are fixed frequency. So you have like 60, 80, or 120 hertz crossover points. You cannot change that. You can't change the slope. You can't change the type of crossover. You want Linkwitz-Riley? Do you want Butterworth? But by taking this little dongle and plugging it into the amplifier and connecting a USB-C to USB or USB-C, whichever your laptop has, I now have full DSP control with this amplifier. Well, what is full DSP control? Let's pull up that software and let's show you exactly what it is. So what we have here, if you notice, we have this little graph, and it's starting from 10 all the way up to 20K, and that's in hertz once again, 20 kilohertz down to 10 hertz. We have our channel selectors here, which we can select which channel I'm adjusting. This software works for the 1000.5, which is the amp that's in front of me. It also works for the 400.4. It does not work on the 3 subwoofer amplifiers. Something else, if we go to settings, you have a light mode and a dark mode. Think that dark mode is going to be easier for them to see, Ernie? I think so. All right, so now we're going to select channel 1, which should be usually amp 1 left. So if you notice, I got this blue line, which means basically we have a flat signal. We've done nothing to change the signal. So first thing I want to do is I want to go down here and I want to set a crossover point. Generally, your amp 1 and amp 2 are going to be high-pass speakers. So I'm going to arbitrarily pick a high-pass crossover point at 80 hertz. And I personally like Linkwitz-Riley crossovers, and I'm going to set it to 24 dB per octave. Notice what happened to the graph. This is not showing us frequency response on the output, but it's showing what we're telling the amp to produce. So there's 2 different types of RTAs. There's one that's showing you the intended signal, and a microphone is used to show you the actual signal. Now, a lot of people ask, what is the difference between a Linkwitz-Riley and a Butterworth crossover? Well, watch the crossover slope right here, and let's go ahead and switch that to Butterworth. If you notice how that crossover point changed and it's got a little bit steeper, the difference is a Butterworth crossover is 3 dB louder at the crossover point, which 80 hertz is going to be right about here. So if I go to Linkwitz-Riley, you see how that dropped 3 dB. There is really, in my opinion, the only acoustical advantage or tactical advantage is overall sound response. There is no right or wrong. One isn't necessarily better than the other. But if you do a high pass and a low pass crossed over both at the same frequency, let's do that. Let's go ahead and turn on the subwoofer, and let's go ahead and get to the crossover, which is down here. Let's set its low pass crossover, do a Linkwitz-Riley, turning it on at 24 dB per octave. Now you see the subwoofer crossover. And let's keep scrolling over here. Here's your, once again, here's your high pass crossover. And that was set at, I'm sorry, I got to keep scrolling this down. And of course your subwoofer, now we can add them together. So now you can see there's this little bit of a dip here at the crossover point, which is 80 hertz. So if we go back to the crossover, slide this down, and let's change this crossover on the blue, which is the high pass. Let's change it to Butterworth. Watch what happens to the crossover. You see how that shifted? Now let's go back to the subwoofer. Here's your adjustment here. Let's set it. Also, set it to Butterworth, and turn on the other channel as well. So now you can see what an effect it has changing the crossover there. So here we have an asymmetrical crossover. You have the Linkwitz-Riley on the subwoofer and a Butterworth on the high pass. And it really is acoustically what you want it to be. And here again, I'm the guy that usually likes Linkwitz-Riley on everything. So let's go back to the subwoofer crossover, and we're going to set it. I'm fumbling around with the buttons here, guys. All right, Linkwitz-Riley on subwoofer, and let's go to the high pass, which is going to be channel 1. And I'm going to set that also to Linkwitz-Riley. So now let's put the two of them together again to see where we're at. Now we talk about crossover slope. And crossover slope, you have a varying degree of cut. So let's go ahead and take channel 1 off. Actually, let's take the subwoofer off. Let's look at the slope. So we have 24 dB per octave, which is a pretty steep slope. I mean, they make 30 dB, 36, 42, 48. I mean, it's infinite in orders of 6. It's always got to be an order of 6 when you come to the roll-off. Now let's go to a 12 dB per octave roll-off. Watch the low-end response of that graph. If you notice how it really started to stretch this out, it's actually playing more of the lower frequencies, but at a very low level, versus the 24 dB per octave that cuts off more of this, but it actually plays harder and then it cuts off a little bit sharper. This is very important for tuning because it's going to decide how much of the frequencies you cut away and how quickly. So if I did a 6 dB per octave, which I don't have that capability, it's a very shallow slope. It's not going to do much in the way of crossover, but they're the simplest components. That'd be like putting a capacitor on a tweeter. It's going to roll off at 6 dB per octave, or just putting a coil on a mid-range. So let's go back and look at that again. Let's change this crossover to 12 dB per octave, or let's see what it looks like if I just shut it off. In fact, if we go to Butterworth, we can do a 6 dB per octave. So let's show you that. So now if you notice how long, that's playing a lot of these lower frequencies. So if you got a smaller mid-range and you want it to have a lot of output in this region, but these lower frequencies are going to damage it, you would definitely want to step up to a steeper slope to help eliminating some of these lower frequencies. So that's what you can do with the DSP crossover. You can change the type of crossover, you can change the slope, you can change the frequency. So let's show you that. In fact, we can do this on the fly. Watch this crossover point right here. Let's start changing the frequency. I'm going to start increasing the frequency, and you see how that does not change the shape, it just walks it away. So what I'm looking at here, if I got this big gap right here, see here's your subwoofer, here is your tweeters or your mid-range, I would say we probably need some type of mid-bass. Let's go to channel 3 and let's put a mid-bass crossover on channel 3 just for fun. So let's scroll this down. And all right, so let's go ahead and go back to our crossover to set Linkwitz-Riley. I'm going to set that crossover point at, let's go up to 80 hertz. Just type it in, it's quicker. And I'm going to set that to 24 dB per octave. I'm going to go to the low pass crossover, and let's just set it at 500 hertz for now. And we're also going to do a Linkwitz-Riley because that just seems to be my favorite. We're going to set it at 24 dB per octave. So now let's turn on the other channels. Let's turn on channel 1 and turn on the subwoofer. What do we have? We have an active 3-way crossover. The major advantage of DSP, especially when we're doing this, is I can now adjust this on the fly, which is going to adjust in real time the output of the amplifier. So I can make very, very simple changes in frequency. I can change, types of crossovers to see how it's going to affect the sound. We can do all that real time, and hopefully we're not damaging the speakers because you never want to do any of this at full power. But it gives you a lot of capabilities. Now, some of you guys ask, well, it's too complicated for me to adjust between left and right. If we go to the setup that we have down here in the setup setting, I can actually take amp 1 and I can link the equalizer and the crossover together, which means anything I do to amp 1 on the equalizer or the crossover, it automatically applies it to both left and right. So same thing if I go down here to amp 2. Anything I do to amp 2 right now is going to be totally independent. If I make any adjustments to the left, it will not affect the right. But if I turn these on, they do link them together. That is another huge advantage of DSP. It allows you to tune these things so much easier. And this is the signal I know I have going into the system. By using a microphone, I can listen to see how close I'm approximating the output of the sound system to the waveform that I want it to show. So this is why DSP is such a powerful tool. And that's just two functions of DSP. That's just crossovers and equalization.